Everyone, welcome to today's session. We're taking a dive into open science in Canada. My name's Claire Ardern, meta science researcher based in Vancouver, where I co-lead the Methods Research Peer Review and Research Evaluation Group, where we study how to measure the impact of research on people and policy in Canada and around the world. It's my pleasure to welcome everyone to this session where we're looking at how to implement specifically open science in Canada, or what we sometimes refer to as open scholarship in Canada. And we've got a wonderful lineup of speakers today who will share their experiences and their views and expertise. And I'd encourage you to do the same, because we're really keen to hear from you. We've got a wonderful wealth of folks, experience of the folks who are joining us virtually, and we really want to benefit from the collective experience and wisdom in the virtual room today. So please use the chat function to engage. Post who you are and where you're zooming in from today, so that we can get a sense of who's joining us. Your experience in open science practice is all very welcome. Please also use the Q&A function for specific questions. We've got time for panel discussion at the end of the session today, so specific questions for each speaker. If you post them while the speaker is presenting, you won't forget your question. We'll pick them up and then we'll put them to us session at the end. It's my pleasure today to welcome my co-host and colleague in Vancouver, Professor Karam Khan, who is going to share the goals of today's session and introduce the first speaker. Over to you, Karam.
Thanks very much, Claire. And this session is about, it was working before. So I can see it was working before. This session is about open science, and it's something that people in this audience will have various familiarity with, and many will think it's a good idea. But on the other hand, there are these forces, commercial forces, barriers to doing open science that aren't making it happen so well. So the purpose of this session is to give different perspectives on how these and research institutions and at the policy level, we can move from talking about open science to walking into open science, which is why the topic is in that way. So my next job is to move to introducing Kara Tannenbaum, which is a great pleasure. And Claire is the master of the polls, and so she's got the polls going there on the side. We want you to think about this poll question too, which is how Canada's doing in terms of implementing open science. So that gives us sort of a baseline, and then with the speakers, making you think about elements you might think, well, we're doing better than I thought, or doing worse than I thought when we get to the discussion. For all of us, really to encourage the discussion and the session at the end. So please engage with that poll question too. How do you think Canada's doing in terms of implementing open science? I'll focus on introducing Kara, and then if Claire wants to engage with some of the comments from the audience, that'll be great, but I'll leave that up to you, Claire. But Kara is a friend, I'm pleased to say, and one of the real stars of Canadian policy and research. She's a departmental senior advisor to Health Canada. She's the scientific director of the Institute of Gender and Health and a professor at Université de Montréal. And on top of all that, in the pandemic, when it was hard to get your breakfast, she managed to do everything that she does, and also co-found CAN COVID, which is from the Office of the Chief Science Advisor and the universities, and that's a unique collaboration and convening people in Canada. So you're going to enjoy your time with Kara Tannenbaum. It's a real privilege every time that I have the opportunity to hear her or to be with her. And so I want to hand over to Kara, just checking with Claire, Claire, do you want to have any discussion from the poll, or should we go to Kara?
Yeah, let's have a look at the poll first. Thanks, Karam. So the first question was about who is in our room today. And this is really helpful for us as a panel group, because we get a sense of who's listening in, and we can tailor how we share and what sorts of information we share to who's in the room. So we've got a great representation from federal government, 72% of the respondents. We had about 30 respondents. We've got some students, we've got some researchers, and we've got some folks who are from the not-for-profit sector. So we've got a really broad spectrum, and it's really great to see such a diverse group here, because open science is for everyone, and I hope that that's a key message that comes out of today's session. Kara, before you kick off your presentation, let me just share the first poll question that's specifically about open science. So here we're looking at folks to give us a sense of how you think that Canada is doing in terms of implementing open science compared to other jurisdictions that you're familiar with. So specifically about Canada, how do you think Canada is doing in implementing open science? So I'll give folks a moment. I can see we've got a few people who have already joined in on the poll. Please encourage you to join in on the poll and contribute to today's session. We're all about co-developing today. So we really want to hear from you and hear what your experience is and your view of Canada and open science implementation. And I can see here, if I share the results, we've got a fair few people who think Canada is about in the middle of the pack, and then about a third of the respondents thinking Canada is behind the curve. So Kara, I hope that gives you a good starting point, and I'm really looking forward to hearing your thoughts on open science. So Kara, over to you to get us started with the presentation and slides. Thanks, Hayden.
Thank you very much, Claire and Carm. Merci beaucoup tout le monde. Il fait vraiment d'être ici parmi vous. I'm joining you today from the traditional ancestral territory of the Anishinaabe, just north of Montreal. I was invited to tell you a story. And the story that I'm going to tell is one of sex and gender-based analysis and how the Canadian Institutes of Health Research integrated sex and gender into their funding policies. And you might say, next slide, please. Well, what does sex and gender have to do with open science? So I would ask you to put in the chat, what's similar between the pictures on this slide, the two pictures? Didn't put a poll question up, but basically you'll tell me, oh, look, they're both government documents. They're both Government of Canada documents. The one on the right is the Roadmap for Open Science, which is a federal priority here in Canada. And that's dated February 2020. And the one on the left was the very first guidance from government on integrating gender-based analysis. And if you kind of squint your eyes, you'll see that the date there was 2005. So 2 government directives, 2 government policies. Next slide, please. Fast forward to today, and the big red numbers, the 80%, 91%, 76%, and 82% on this slide, are the proportion of Canadian researchers who are integrating sex and gender into their health research when they apply for funding at the Canadian Institutes of Health Research. That's not bad. Wouldn't you like to see a slide like this that said what proportion of government scientists and Canadian scientists were doing open science? But then if you look at the small writing underneath in white, you'll see that if we flash back to 2011, 6 years after that first gender-based analysis policy document came out, only 15% in basic science, 30% in health systems research were actually integrating the policy. Next slide, please. So how did we get from those white numbers to the red numbers? And why did it take us 15 years? What can we learn for open science in order to do it just as efficiently, effectively, but more efficiently and quicker? So I'm going to tell you what I see as the steps to get us there. Next slide, please. So step 1 was we need data. In 2010, so the CIHR put a box, we call it the sex and gender box, but put a box on all applications for health research applicants in Canada, asking, do you take sex, biological considerations into account in your research? And is gender, sociocultural considerations taken into account in this study? If yes, please describe how, and if no, please tell us why. Until 2010, though, we had no way of knowing where we stood. So those of you who answered the poll saying we were ahead of the curve or on the curve or behind the curve, how do you actually know? Driven. Next slide, please. So what happened? Well, you could see those initial numbers back. So the x-axis here are the years, and in light blue teal is how many people said that they took sex into account, and in the darker green is how many people took gender into account, and on the y-axis you see the proportion of researchers. And certainly in 2011, which is when we got our first data point, there was not even 20%, 1 in 5 who were doing it, 1 in 4 who were doing it. And then when we kind of said, well, you didn't justify why you weren't doing it, and you have to answer, suddenly it increased to 50%. So take home number 1, if you ask people to actually say what they're doing, they may be more motivated to go, oh, wow, yeah, I should really do that. Okay, I'm gonna do that. That's an easy one. Next slide, please. But did they actually know what it meant? So did I integrate sex or gender into my proposal? Well, hey, I'm a woman. Yeah, I guess sex is integrated. No, that's not the way it works. So step 2, you need to educate. Do people know what open science is? Do people understand what data sharing is? Maybe they think open science is publishing your paper or putting out a report internally. So education is key. And here, as you see, I'm hoping you're reading that and learning about sex and gender if you don't know it yourself. That's not the point of this presentation. So over to the next slide, please. Educating is very important. You need training on this. So some people don't like the word training. We prefer the word learning. And you need to make it relevant to context. So here we actually developed and posted in 2015 3 online training modules, some for basic scientists, some for clinical scientists, some for health research scientists and epidemiologists, because what I'm going to extrapolate here, what open science means to different stakeholders in different disciplines is going to be different, and maybe the one size fits all doesn't work, and everyone adopts behavior change according to their own personal lives, right? Next slide, please. So you want to educate. When we did this, when we educated, did it help? Well, it pushed the curves up by another 30%, which we were happy to see. So because we have data, we're able to see what works and what doesn't. We also at this time launched what we called Sex and Gender Champions. And for some funding competitions, we said that you needed a champion on your team to guide you how to do this properly, because maybe you don't have the skills. Next slide, please. Step number 3, we have the training. We tell people to report it, but what's the motivation here? You could just check off no and still get your grant, right? So we put in place a number of carrots and sticks. We threw money at the problem. We had catalyst grants, and we said, well, maybe people have to complete these training modules. So you can't even apply for a grant unless you show your certificate of completion. Next slide, please. But just because you completed a 45-minute online course doesn't necessarily mean that you're convinced that you have to do it, or that you have the skills how to do it, or that someone tells you if you're doing it properly. Also, folks had a lot of questions. So I'd say lesson for open science is, what about those financial barriers? When we started saying people had to take sex into consideration and include males and females, male and female animals in their study, because, hey, how could you extrapolate for a woman if you're not even looking at female biology when you develop drugs, or medicines? They said, oh, that's going to cost me double. I need twice as much cage space. I need, that's not really in line with good animal care policies. So addressing the pushback and the feedback and talking about the reasons how you could have more efficient design where, as we say at CIHR, we're not going to refuse you. We're not going to say, no, we're not giving you money to include those female animals. So don't tell me it costs more. I'm telling you this is what needs to be done in order to develop research results that will benefit all of Canadians. Next step, or next slide. So we did that. And then, so now people are filling it in. And 5 years into this, someone stands up at a conference and says to me, but Kara, is anyone even reading the box? Like, is anyone even, seeing what I write? And I went, whoa, good point. So what we had to do is we had to introduce a page for the reviewers, who's policing this, to check off when they read, like, is this okay? Is it okay that you're not taking it into consideration? Or if you are, good for you, you should get points for that. Or maybe I agree this isn't applicable to your study. So we introduced that and started providing feedback from the peer reviewers at CIHR to the applicants. Next step, please. Well, that worked up to a point, except just by saying I'm doing it, or for the reviewers to say, good, you're doing it, was more about the quantity and not the quality of the response. So something to think about for open science is it enough to do some of open science? Is it enough to, I don't know, have open access on your publication after a year? Or if you're not data sharing, if you're not, I don't know, sharing preprints, if you're not, so the quality of what you're doing needs to be taken into consideration too. And how are you analyze and measure that? Next slide, please. So that leads us to my, I think, final step, which is step 6. We need to coach the auditors and the evaluators so that they know, is it good enough? And what we did is we developed a new set of training. We developed a 3-minute YouTube video. We developed checklists so that the reviewers can say whether not only is it the correct quantity, but the correct quality of application and implementation that's occurring. The good news is, next slide, is that it worked. It took 15 years, but these steps fundamentally change culture. And what these graphs show on the x-axis is the competition cycle for CIHR, and on the y-axis is the odds of getting funded if you received a rating of a strength by the reviewers, by at least 2 out of 3 reviewers, on how you integrated sex and gender. And for instance, if you look at the gender graph here, it shows that by 2 years ago, the odds of you getting funded were 2.5 times higher if you successfully integrated gender into your human relevant applications than if you didn't. So that means that it's now a part of the definition of scientific excellence here in Canada. And I think that's what we're aiming for with open science. Next slide. So is a policy enough? Is a mandatory requirement to report enough? It's a good start, but it won't be enough unless we have capacity building, incentives that address motivation, monitoring, and quality assurance. I'll leave you with my last slide, which is the roadmap as I see it for what we need to do to move open science to putting us ahead of that curve on the poll that you just put up, Claire, for Canada, because I always like to see Canada in the lead. I'll stop here, defer to my other panelists, and look forward to taking questions at the end. Thank you.
Thanks so much, Cara. That was wonderful. I think one of the key messages here is that we've got to get measuring, because you can't see what's going on and change if you need to change if you don't measure. And I loved the practical tips there as well, Cara. Things like learning incentives, so lots of great examples there and lots of food for us to work through and digest as we work through our panel and then get to the panel discussion at the end. Thank you very much. I'm going to launch our next poll question and then I will introduce our next speaker. So coming up in your screen, and again, really encourage folks to engage with the polls and share your knowledge and experience, and also engage with us in the discussion forum and the Q&A. So the Q&A for specific questions that you'd like us to ask of a particular panelist, and the discussion forum for more general discussion, introducing who you are and where you're joining us from is terrific. So you can see here the poll question, next poll question that we've got is looking at open science practice and how we evaluate that. So let's see what folks think about whether open science practice should be evaluated as part of a researcher assessment. And you can see here that overwhelmingly people are saying yes, it should, which leads beautifully into our next speaker. And so please let me introduce Dr. David Mower. Professor Mower is interested in bringing assessment of researchers into the 21st century. And David, looks like we've got some people here joining us today who are keen to help on that jump on that train. So we're in good company. Dr. Mower has a sustained interest in making the assessments of researchers evidence-based wherever possible. He is the senior scientist at the Clinical Epidemiology Program, the Ottawa Hospital Research Institute, where he directs, the Centre for Journalology in Publication Science. He's also professor in the School of Epidemiology and Public Health at the University of Ottawa. Dr. Mower is an associate director of the International Congress on Peer Review and Science Publication. So Professor Moa, over to you. Let's hear about researcher assessment, please.
Introduction, and what I'll start with is sort of what goes on in my life. So in my annual assessments, they're really interested in how many papers I've published. They're particularly interested in papers that I've published in journals with an impact factor of 5 or above. They're also interested in the number of grants and contracts that I get, and they're particularly interested in my H index as well. And so I'm not rewarded whether I've registered my research, which is mandated by the tri-agency, federal funders. They're not interested in whether my research is openly available to others, which is also mandated by the tri-agency. And they're not interested in whether I've shared my data or code with any of my publications, which is now being mandated also by the tri-agency. And so the question is, am I a statistical outlier? Is the Research Institute a particular outlier, or is this going on more generally? And so we sought to look at this by going to about 170 academic institutions, principally universities around the world. And we really asked 12 questions about how people were assessed for promotion and tenure. 5 of the questions were sort of traditional metrics you might expect, such as the ones that I'm assessed on, simply the number of papers that have been published. And we also asked 7 questions about sort of perhaps progressive criteria leaning towards open science. And so, for example, we asked whether any of these criteria for open data sharing was part of the researcher assessment. And as you can see from the bottom bar chart, that actually in the vast majority of cases, that the way somebody progressed through their career from to promotion and tenure was based on very traditional criteria. So my institute is not alone. That seems to be what's going on in the world more generally. And so the question is, should academic institutions incentivize and reward open science practices? And really, why would you want to think about open science? And I don't have time today, but I think it's quite easy to say that the current incentive scheme is somewhat or completely broken, depending on your perspective. I just give simply 2 examples. Peter Higgs, a theoretical physicist who came up with the Higgs boson, it had very, very few publications and felt extremely guilty about this based on he was at the University of Edinburgh based on their sort of traditional criteria, but he did go on to win the Nobel Prize. So perhaps the number of papers is not nicely correlated with impact and success. Another example is the wonderful writer Atul Gayawandi, who's an oncologic surgeon, who really wrote a wonderful article and book about dealing with the end-of-life care for cancer patients. None of this work, as impactful as it was ever published as a research article. So maybe the number of publications is really not particularly relevant. As most of us will know, that the journal impact factor is not a measure of quality. There are over about 2,000 organizations around the world that have signed DORA, which is a declaration of open research, research assessment. And I think what DORA is principally on about is actually getting rid of GIF as a part of career assessment. And the Canadian federal government promotes is an open government and it promotes open scholarship, but they are perhaps lost in translation. And I hope that the example I've given is simply one example, is sort of they're not used in research or assessment. And again, another question as to why open science. There's an emerging corpus of evidence about open scholarship. Open science will promote transparency. It'll certainly help reduce waste in research, for which there is a tremendous amount, and is likely a catalyst for EDI. And it will promote both scientific and citizen community engagement, which is very important. And what can sort of institutions do? One is they can think about institutional education, training, learning. For example, Dr. Kobe and I teach a graduate course on publication science, and I think the very consistent feedback that we get from students, not prompted, but this is what we get, is why isn't the course taught across the university, and why isn't the course mandatory? And it's sort of quite interesting because at our institute, I must do mandatory training. So for example, I have to do WHMIS training for labs. I've never been in a lab. And so it's strange. And if I don't do this training, there's quite an easy solution. They simply cut off my email. So there's quite an incentive to do this, and one could think about doing this for open science as well. And patients really think that open science is important, and there's an increasing number of papers showing that patients feel very strongly about wanting to share their medical data in terms of for research purposes. And we have growing evidence that data sharing is associated with added value. There are citation advantages for linking publications to research data. And this is probably something important for universities. And it's interesting that they still don't ask about data sharing. And I think funders can also really act upon it. Canadian funders, both federally and provincially, could think about having specific funding opportunities for open science research. This goes on in the UK, such as the Wellcome Trust and the Research England Development Fund. And obviously it goes on in Europe, and I've simply given you one example of a funder who provides specific funding calls for open science. I think organizations, academic institutions, universities could definitely take some leadership here, and they could commit to asking what are the benefits of open science. They could also remember that this sort of initiative is going on around the world. And in work that Dr. Kobe is leading, we are asking university and hospital leaders about using open science in research or assessment. We've engaged over 15 institutions, and we have over 80 respondents. These are people who are in leadership position, sort of asking them questions about the use of open science within research or assessment. And we will be having a consensus meeting in March of 2022. It's also possible to think about picking up a point that Cara made about auditing. And here is an example on my left hand is the Charité Hospital, which is the largest teaching hospital in Europe. They have a dashboard, an open science dashboard, where you can see whether the percent of journals that are open access, the number of preprints that are being used. And in yesterday's Nature, Malcolm MacLeod, who is in a leadership role at the University of Edinburgh now, is really sort of calling upon the use of dashboards as a way of providing audit and feedback to universities. there's no reason why this couldn't be extended actually to provide a similar sort of audit feedback to funders as well. And that's all I have to say. So thank you very much. And I think back to you, Claire.
Yep. And that'll be, I'll take it from there to say thanks to you, David, and launch the next poll question. We'd like to give everyone a chance to keep engaging with the poll, and thanks for the contribution so far, because it really helps the speakers. So I'm going to start this question for folks to read, which is about research funding organisations publicising open science policies more, and would that in itself lead to improving practice? So I'm going to introduce Dr. Kelly Kobe, who'll touch on this and give you insight to the question. Kelly, it's been a great privilege to get to know you over the last 2 years, and you're at the Ottawa Heart Institute now, the University of Ottawa Heart Institute now. And what I want is, you made it really clear about your passion about decreasing waste in research and your passion for increasing research. You've got that international experience that comes from Netherlands, which is clearly a great country in this space. A couple of key elements from your terrific CV are that you're a member of Equator Canada, which will rest our audience. You're on the advisory board of DORA, which is fantastic, and you're an associate prof cross-appointed with the School of Public Health, the School of Epidemiology and Public Health, obviously. So you're one of the leaders in Canada and internationally in open science in this field of meta-research, of journalology. It's the floor.
Thank you so much, Karam. Just to say, I'm calling in from Algonquin and Anishinaabe territory, and a couple of declarations. So as Karam mentioned, I'm on the advisory board of DORA. I'm also on the Science Policy Committee for Research Data Canada, and an ambassador for the Centre for Open Science. These are all sort of unpaid voluntary roles. Okay, so I'm going to be talking more about data sharing. We've heard a little bit from Dr. Mower about this. When I say data sharing, I mean the practice of making data available for reuse. So most commonly, this is done, for example, through putting data in a public repository, but it can also be achieved through publishing data on a journal website. And when I speak of data, I think, I mean it in the broadest sense. So often when we hear the word data, I think a lot of people think about spreadsheets, and that is data, but data can also be notes, writings, photos, images, videos, and so on, and much more than even what I have here on the screen. So thinking of data very broadly, and how that data might be shared is the focus of my talk. So this begs the question, why would we bother with data sharing? We haven't actually traditionally done data sharing, so what's the impetus? And I think there's a lot of value in sharing data. I've outlined 3 reasons here. So the first is that I think sharing data increases the trustworthiness of research. It allows for transparent documentation of research data. So at the very least, it can show us that a study reported has data associated with it, but it would also allow others to validate that work, say reproducing the analysis. And further, I think it increases trustworthiness and promotes equity by allowing open engagement of everyone with the data that's shared. Secondly, I think data sharing fosters knowledge and innovation. So for example, you can aggregate multiple data sets together and synthesize the results. And I think this can, and practices like that, accelerate knowledge transfer. And finally, I think data sharing can be really economically efficient. So while there's certainly sometimes very good reasons for reproducing and replicating studies, in other instances, this may make less sense, and data sharing can promote the avoidance of unnecessary duplication. As David mentioned in the last talk, there's a great deal of public support for data sharing. In our country, in Canada, a lot of research is funded by tax dollars. So I think, the public and patients are quite supportive based on evidence. So this is a study done by Mello and colleagues of 771 recent participants in clinical trials. And what they found was that 93% were very or somewhat likely to allow their data to be shared with other university scientists. So I think that the sort of moral support for this is there from the community, and we need to move from the idea of valuing data sharing to actually implementing it. So in terms of implementation in the policy framework within Canada, for academic institutions and universities, the most relevant policy, I would say, in this respect is the Tri-Agencies Data Management Policy. This policy was introduced in March of this year and has three basic sort of sections. The first is that the tri-agencies will be implementing data management plans starting in the spring 2022 competition in some format. Then within a little over a year, they'll expect all institutions receiving tri-agency funding to have institutional strategies around data management. And finally, we'll move towards a requirement for tri-agency funded research to have data deposited in some sort of repository. So there's no timeline on that, but it's the idea that unless there's a reasonable, exceptional circumstance for sharing your data, if you're funded by the tri-agencies, your work will eventually be going into a repository. The other policy that is relevant, which Kara Tannenbaum mentioned in her talk, is Canada's roadmap for open science. And this has an objective to provide overarching principles and recommendations to guide open science more broadly and those activities within Canada. And I think this is a great starting point for Canada. This was in February 2020 released. But I think that the framing of this is really around federal government departments. And we don't have sort of a parallel document for the university or research institution setting, despite the fact that we're often receiving public funding. So I think policies such as the two that I've just mentioned are an important part of the puzzle, but they're insufficient on their own to implement data sharing. So this begs the question of how can we ensure the success of data management policies? And what I'm going to do is I'm going to go through 5 things that I think we could be doing to ensure success. And the first is just broadly recognizing that implementing data management and sharing practices is a behavior change problem. So one of the things we're going to need is training and education. This needs to be widespread. Right now, there's absolutely no formal or standardized training on data management or sharing. So again, in Kara Tannenbaum's presentation, we heard how training on sex and gender and the implementation of that at the tri-agencies resulted in the implementation of that sort of understanding and output within research. Such a process has not occurred for open science practices, including data sharing. There's also no clear incentive for researchers to do more than the minimum standard. And there's a lot of changes happening. So very basic things like the FAIR principles or the OCAP principles, or knowing actually how to share your data, they're coming out and changing very rapidly. And I think the average researcher, it may not be keeping pace. The second thing we need is funding for data sharing. So the reality is that if in Canada we want to start managing our data robustly and eventually sharing it, there's a time cost, there's an infrastructure cost for particular types of data especially, and there's a personnel cost. And so we'll need money to do this, but I want to make the point that lots of research that's conducted in this country in universities and research institutions is not federally funded. Some research is even unfunded. So we need to somehow capture that in our attempt to implement funding for data sharing. Thirdly, we need audit and feedback on data sharing. So again, Kara talks about how this was important for the eventual implementation of sex and gender policies. In the open science space, we actually have a recent example of an audit by researchers based out of Montreal, where they looked at how when CIHR had an open access policy that they then harmonized with the other tri-agency groups, how that actually led to a decrease in open access publications. So, the idea of having a harmonized policy seems intuitive and to make sense, but it actually decreased open access publishing from 60 to 40%. So I think this highlights the point that, we may have great policies or views or ideas, but if we don't audit them, we don't know if we're doing a good job, a bad job, or making no change at all. Finally, I think we need meta science on data sharing topics, as well as other open science topics. So we need research on research, and we need funding to do that. And as was highlighted in David Moore's last talk, we need to link open science practices such as data sharing to career advancement. So in the absence of incentives, I don't think this will happen. Right now, it's a game of quantity. So the more the publications you have, the better it is in terms of researcher assessment, and there's little emphasis on quality. I think in terms of recognizing this as a behavior change problem, one thing that we ought to do in Canada is develop a data champion program. So Kara mentioned having sort of sex and gender champions on grants. Well, in other jurisdictions, including within Europe as well as Australia, there are actually programs to create data champions to create a culture change and awareness on the grounds from a grassroots perspective around data management and sharing. And I think our country could benefit from this as well. I'm going to stop there and then pass it back over to Karen and Claire. But I just wanted to highlight that if you're interested in this topic, our team, so David Mower and I, as well as Felicity Taylor and David and I, have written a couple pieces on this topic, and I'd be keen to engage more in the discussion as well as offline. So thank you very much.
Thanks, Kelly. Brilliant. And I'm hearing lots of links across the different presentations, lots of great threads coming through around how do we measure, what are we measuring, what's important to measure, who pays for these things, and how do we get buy-in from all of the constituent groups that are critical to making open science work in Canada. And I also want to point out that in the poll response, a lot of people were saying that publicity for these initiatives is not enough. It's not simply that research funding agencies publicize open science policy. We've got to do more than that, and I think that's coming through in all of the presentations that we've heard so far. So the other thing is that I'm really pleased to see so much chatter going on in the discussion forum, and we've got some questions coming in on the Q&A, so please do keep those questions coming in. We have lots of rich fodder for our panel discussion at the end. I'm going to launch our last poll question now, and then I'll introduce our second last speaker. So poll question should be coming up on your screen now. We're looking at what's the most important aspect of evaluating research output from your perspective? Is it quantity, quality, or popularity? Or perhaps there's something else that's missing there. And if you feel like there's something missing that's really important when we're measuring research output, pop that in the discussion forum and we can pick that up in the panel discussion at the end. So what do you think is the most important aspect of evaluating research output? And that leads beautifully into introducing our next speaker, Dr. Michael Hoffman. Michael's a computational biologist with a long commitment to open data and code. And he's a senior scientist at the Princess Margaret Cancer Centre at the University Health Network. And he's associate professor in the departments of medical biophysics and computer science at the university, both at the University of Toronto. At the University Health Network, he leads a group who are trying to find health. I'm really looking forward to learning more about measuring. We're talking more about measuring, but particularly measuring the impact of health research. And I can see here that there's a lot of folks who are saying that quality is the most important metric. So let's hear from you about measuring impact. Michael, over to you.
Thank you very much, Claire, and thank you for the invitation to this session, Kelly. So I'm going to talk about evaluating research after DORA. I have no relevant competing interests for this talk. So it was nice to be able to get the poll in advance. 97% of the respondents said quality was the most important thing. Right? No one said quantity, but what do we actually measure when we look at what researchers do, or institutions? Often we're looking at the number of publications or the number of publications in certain kinds of venues. We don't usually look at the size of publications. That would be kind of silly, but I'm not sure that looking at the raw number of publications is any less silly. And people like to, aside from just looking at the quantity of publications, people like to look at a lot of numeric indicators that I would argue are mainly indicators of popularity, right? So these go back mainly to number of citations, which is an indication of how many people have talked about this work. And people like to say that this has something to do with the quality of the work, but really people have studied this over and over again and found that it's not necessarily related to the quality of the work. Sometimes really bad papers can have a lot of citations because they are really bad. Even worse, sometimes people are looking at number of citations to other papers in the journal, and there's just been lots and lots of scholarship about why this has been a problem. And people like to look at other aspects of popularity too. Alt metrics, I'm not going to talk about that, right? But really what most people think is important is quality, right? Why aren't we measuring quality? Why are we stuck on these popularity-based metrics? So as David mentioned, DORA has been an attempt to get us away from some of these popularity-based metrics, especially journal impact factor, and onto measuring things more like quality. I had the advantage of seeing everyone else's slides because I did mine at the last minute, so I saw no one really introduce Dora. Also, because it's the last minute, I thought I would search the internet for Dora slides that I could just pop in here. This is what I got. It was less helpful for this, but as a parent of a toddler, I think this will be very helpful in the near future, Dora the Explorer. Okay, so Dora is the Declaration of Research Assessment. Dora is a initiative to improve the assessment of research, especially to get away from evaluating research by journal impact factor and getting away from evaluating research by the journal that it appears or venue it appears in as well, evaluating all scholarly outputs and so on. And there have been a number of Canadian Dora endorsers. I have to thank the leadership of the first 5 funders on this list, especially the Tri-Agency, CFI, and Genome Canada have endorsed Dora. And while implementation is still kind of unsure, I think this is has made a huge difference. And I think many of the other groups lower down on the list have endorsed Dora in response to the Tri-Agencies endorsing it. And it's great. But what does it mean? How do you actually put this into practice, stopping evaluating people based on journal titles and starting to evaluate them based on quality, which is what everyone says that they want? So I'm at the University Health Network, which is one of Canada's largest research hospital and another Dora endorser. I'm a senior scientist here, but I also serve on a couple of working groups or advisory groups that are attempting to answer this as, among other questions, how do you evaluate research better? All right, and I just want to say we haven't come to any final recommendations. This is all under discussion still. So I'm just going to give you my opinions from what I've learned in a lot of discussions and research over the past year and a half at UHN. So first, let's consider, when do institutions evaluate research? For researchers, they're evaluated at hiring. They're evaluated at annual review. If you're at a research institute, there's usually some sort of periodic deep review. So I get evaluated every 5 years in a deep way, right? And if I don't pass my review, I lose my job. We don't have tenure here at the research institutes. It's a little bit different if you're a tenured position. But even if you are, there's still promotion review. You get reviewed going into tenure, you get reviewed for promotion to full professor. And organizations also have their own sort of reviews. Often there will be some sort of annual review by someone one up from a department, like the dean, and a periodic deep review. So in University of Toronto, each department is evaluated externally every 5 years. Since our time is so short, I'm going to focus mainly on researchers here. And what do we learn about evaluating research? Well, first, I want to if you take away one thing from this, right? I want people to understand that doing the same thing over and over again and expecting different results is profoundly silly. And that doing the same thing over and over again is evaluating people by submitting a list of article names and journal titles to overworked reviewers. Okay, so there are 2 components to this. We say we want to stop evaluating people by journal titles and start evaluating by quality, right? But still, what is usually provided to reviewers at any of those kinds of reviews, hiring, annual review, deep review, whatever, is just a CV with a list of journal articles and journal titles, right? And the second thing is overworked reviewers. If you want this to be reviewed well, it's going to take time. And if you have someone who has 65 direct reports as their professors that report to the department head, they aren't going to be able to do a good job on this if they just add it on to their nights and weekends. People are going to be looking for shortcuts. So I'm just going to mention a few things that I think will help on both the researcher side and in what we submit, and on the reviewer side, what is looked at. And if you have more questions about what I mean by any of these things, or to expand, you can ask about it for the discussion. But first thing I want to say is that you have to ask the researchers for a narrative articulation of quality and impact. So stop just asking for a CV with a list of publications, right? And then making the reviewers, who are not always directly next to the researchers in area of research, try to figure out what is good, right? What is good, what has high impact? They don't know. The researcher is the person who has is best placed to articulate the impact and quality of their own research, right? And this is something researchers do every day when they write cover letters to journals. So one thing you can do is just, ask them to put that as a paragraph below each paper in their CVs. You can ask them what formal standards did the work meet. Kelly mentioned Equator, right? If it meets Equator standards, put that sort of thing. And also, how are people's data and materials reused by others? That's currently something they don't get credit for unless they insist on authorship for this reuse, which is sometimes unethical, right? So I want to say, how often was your data reused by people who you aren't collaborating with? That's really the proof in the pudding of how good you are at open data and open code. For the researchers, I must say good review is time consuming, but if you do it badly, it's costly. There are all sorts of bad effects of just relying on all these shortcuts over and over again. Fully quantitative approaches, you get stuck in these metrics. Qualitative approaches are biased. Set up a rubric, right? Instead of just evaluating someone overall with their whole gestalt, look at each paper, and grade them on, quality impact. And finally, I want to say, look at their best papers. Are they good enough? Look at their worst papers, right? Randomly, papers they didn't choose as their best. Are they good enough? You need to get away from emphasizing quantity. And one way to do that is to have people focus on the quality of a couple of papers. Now, I'm happy to discuss any more of this in detail, and thank you very much.
Thanks very much, Michael. And it's my turn to introduce our next speaker, and that's Ellen Almoli. And had the pleasure of seeing Ellen at work with the Ottawa Journalology Group. Ellen's got a terrific CV and includes being an undergraduate at McMaster right now in the BSc in the Honours Life Sciences. She's got a major interest in neurosciences and a minor in psychology. Ellen has won a Canadian Standards Association Group undergraduate research scholarship, and that allowed her to study predatory journals with the Centre for Journalology at Ottawa Health Research Institute. I don't want to steal Ellen's thunder here, but I'll give you a clue that she worked on the digital journal authenticator, and this is a tool to detect predator journals. And some people aren't familiar, think it should be easy to detect a predator journal, but it's actually very difficult. So I'm really looking forward to your talk today, Ellen.
Hello, and thank you, Dr. Khan. It is a pleasure to be able to provide my perspective on implementing open science early on in academia. As mentioned earlier, I am a second-year undergraduate student at McMaster University, completing my bachelor's degree in Honours Life Sciences with a specialization in sensory motor systems. During my time so far as an undergraduate student, I was quickly able to recognize the value and importance of research, and therefore the importance of research being conducted according to a set of scientific standards or best practices, one of which is open science, which I hope to talk more about today. The first time I was introduced to the concept of open science was during my time as a volunteer and later on as an intern at the Ottawa Hospital Research Institute. This was through the research paper I was working on under the supervision of Dr. David Moore, the panelist who spoke earlier today. This paper was answering the question, has open science penetrated academic hiring practices? And by discussing the results, I will highlight my perspective on why it's important to implement open science early on in academia, starting at an undergraduate level. We investigated if open science is currently considered to be a requirement or advantage that employers look for when hiring. However, after reviewing more than 300 job advertisements across a wide range of disciplines, such as psychology and health sciences, only 2 job postings, which is less than 1%, explicitly mentioned anything about open science. One explanation for such an alarmingly small number is the gap between the recognition of the value of open science and its actual implementation in academic research institutions. We know open science adds value, but these findings suggest that we have struggled with its implementation in the academic workforce. As an undergraduate student who is highly invested in research, I have been taught about characteristics of science, including the importance of science being transparent, accessible, and a collaborative effort among the scientific community. Interestingly, I also have been taught about the different aspects of open science, such as open access, open methods, and open data. However, I wasn't fully introduced to the concept of open science except through my work at the Ottawa Hospital Research Institute. Out of curiosity, I wanted to see if any of my peers based in all the different universities across Canada have been introduced or know of the concept of open science. Unfortunately, the majority answer was no. This is surprising when considering that research and scientific literacy is a skill set that students of all academic backgrounds need for employment positions of all types, such as in the healthcare field or even in federal agencies. To further illustrate my point, Dr. Colby and Dr. Mower teach a master's course at the University of Ottawa about open science, and the constant feedback they receive from their students is how beneficial and fundamental the new knowledge they have gained has been to their understanding and implementation of research practices. Some upper year graduate students even speak to how helpful the course would have been earlier on in their studies. So knowing that there is a gap between teaching open science and implementing open science in the real world, why would it be important to implement open science teachings early on in academia? Well, there are three main reasons. Firstly, early teaching of open science will facilitate the transitioning of open science skills and application into the workforce. Secondly, it will strengthen the collaborative nature of research among the scientific community. And lastly, it will solidify the teachings and practices of open science. Let's talk about each point in more depth. Firstly, to answer the question of why it's important to implement open science teachings early on in academia, we have to think about the big picture. Thousands of students graduate every year from undergraduate programs across the country. Some of these students pursue another academic degree, a master's, then a PhD. Some of these students apply to different graduate schools to work in, for example, the healthcare field. Others get employed in all different types of positions, in businesses, federal agencies, and so on. One thing that is common for all these students is that no matter what the next position they hold is, they will directly or indirectly be involved in research. This is because research is no longer a position enclosed in a research institute. Rather, it's a multifaceted, nuanced, and complex concept that has found its way in all of these position types. It is why Canada prides itself when it comes to being one of the world-renowned leaders in research, with universities like McMaster, Canada's most research-intensive university for the fourth year consecutively. Therefore, knowing the importance of research in the workforce and upper year degrees, it only makes sense that students learn and understand the fundamental features of scientific literacy, one of which is open science. Teaching and clarifying the concept of open science, its characteristics, and how it's achieved early on during undergrad is a skill that will be learned and developed, and therefore transition with students into their upper year studies, research positions, and the workforce. Therefore, like any other skill, it's not age-related. And so by introducing undergraduate students to the concept of open science, its practices and implementation later on will be easier. In fact, this would actually address part of Canada's current struggle when it comes to implementing open science practices in the workforce. Secondly, the collaborative nature of science is prided and encouraged among the scientific community and members of the public. Open science is a mechanism to further promote collaboration, such as through data sharing or material sharing. Specifically, in an era built off of technology, underpinning research with an open science perspective has never been easier. Lastly, why should institutions integrate open science teachings early on in academic careers? The answer is because it will further solidify and strengthen open science as a movement. If you learn something at the onset of your research career, you will have these skills as you move forward. This is much easier than creating behavioral change among established researchers by trying to get them to suddenly implement open science when it hasn't been part of their workflow. So now that we have discussed the importance of open science and having it in academia, how can we integrate it and what steps should we take as a community? The first step would be teaching students and the members of the scientific community about what open science is. What are the characteristics of open science? What does this term mean? How do scientists establish open science? And why does open science matter to me as a researcher, as a student, and as a member of the community? All of these are points that we need to clarify and address in order to strengthen the implementation of open science as a movement within our scientific community. Because in order to advocate and recognize the value of open science, we need to first of all know what it is. We have taken the first step today through our conference and by initiating the discussion about open science. Some of the other next steps could be translating these teachings into the classrooms of universities, research institutions, and workforce positions. Thank you again for your time and for having me today. I will be available during the Q&A and the panel discussion to discuss any questions about open science or any other questions that you might have. In addition, please feel free to reach out to my email listed on the slide. Thank you again.
Thanks, Ellen. That's a wonderful overview of a different perspective, and sometimes a perspective that I don't think we get from the undergraduate perspective. Often we're hearing from researchers, or we might be hearing from policymakers about open science and open scholarship. So wonderful to have your perspective. And thanks for reminding us about why open science is so important and how we can start to embed open science, open scholarship practices at the grassroots of education. I'm going to wrap out. So that's the end of our individual panel presentations now, and we're going really well for time, and I can see that folks have done a great job at engaging with the content today, using the discussion forum. We've got some wonderful questions in the Q&A box. I'd encourage folks to continue posting your specific questions in the Q&A or your general comments and thoughts in the discussion. We welcome comments and thoughts as much as we welcome specific questions. You can also upvote questions in the Q&A if you'd really like us to ensure that we get one of those questions to the panelists. Please upvote it, and that'll make sure we see it and make sure we make it a priority to get an answer for you. I now would like to hand over to my co-moderator, Professor Khan, to kick us off with the discussion panel, and I think our technical team will also help us bring all of the panel members in for our panel discussion. Thank you, Professor Khan.
Pleasure, and congratulations to all the speakers, and thanks for our AV team to be doing the magic and having everyone here like this. So thank you all. So the most upvoted question in the live question answer is from Leon Cheng, and Leon asks if members of the panel could speak on the potential conflict between open science and research in the publishing space, and it links to a question from and Leon also made the point about hoarding of data and potentially being scooped. So a couple of mindset issues that are often brought up as barriers to open science. So I'm looking at the panelists to see who is smiling and jumping at their screen, and I think just go for it. David's smiling the most. Cara, do you want to smile a bit more and go first, or should we let David go? David, I think you've got it.
No.
Let David go. I'm here,
I,
David.
I think I need to hear what the question was again.
Sure. It's about the barriers to open science, including the publishing issue, like obviously the journal, sure. The commercial bit. This idea of hoarding, that if you give open science, Leon makes the point, someone else might scoop your data and publish, stuff that you haven't thought of first. So it's really the scooping concept. So it's the.
So I think in terms of the scooping point, I think it's a definite worry that people have. There is no evidence that scooping goes on in a particular major way. No doubt there are one or two examples of scooping, but in the vast majority of cases, there is no evidence that people are scooped. And one might argue also that in an open scholarship situation, that being scooped could be detected quite easily. In terms of publications, I wonder whether Leon is talking about that people try to publish in high impact factor journals, because that's in a sense how they're awarded in 2021. And there's no doubt about it that open access journals in general, they do not have as high impact factors as some of the subscription journals, and that's part due to history. They're in a much newer transition. The point is that if DORA could be implemented, which I think there is very strong evidence for, not the journal impact factor. Journal impact factor is not related to quality. And most people I've heard from today indicate that quality is very important. It would be very nice if people who published were actually valued on they've shared their data for reuse. They've shared their code. They are making knowledge available quicker by using a preprint. So those are the sorts of examples that I think are evidence-based and speak to something that is far more appropriate than a journal impact factor.
Lee, can I bring you in on this discussion, please? And we've had in the Q&A and in the discussion forum, we've had folks asking about some practical tips for how they can ensure integrity and safe sharing. So, and I know that you talk about this a lot with your colleagues, you teach on this. So what would be your top, say, 3 tips for folks with sharing data and doing it in an ethical and safe way?
Yeah, sure. Thanks, Claire. I think that the first thing I would do is, if that's something you're concerned about, is try to educate yourself. So the standards in particular disciplines with specific types of data can differ quite considerably. So you need to know sort of what mandates and standards sort of apply to your data. So there may be resources at your institution that can help you with that. Another thing that I think would be a really important starting point would be to make a data management plan. So, I think in some way, researchers always, in their protocols, for example, speak a little bit about how they're maybe going to analyze the data. But I think the vast majority of researchers don't make comprehensive data management plans. And a significant component of a data management plan talks about data handling, data preservation, data security, these types of things. So having that plan laid out from the front end of research is, I think, really important. And just to mention for those who may not be familiar, in Canada, Portage has produced a tool called the DMP Assistant, and that's something that you can use to sort of structure that data management plan. I think it's quite valuable. And again, it can be specified to the type of study or type of data that you're dealing with. And I think that the other and final point would be that if you're unsure, you need to ask. So you need to seek out information because, for instance, for myself working in biomedicine and consulting in this space, I know there's a real fear among researchers, even if they're open to the idea and supportive of the idea of data sharing, they don't want to inadvertently share patient data inappropriately. So I think that we need to be moving towards being open, but that we need to do so in a way that is open in terms of, acknowledging sort of our own shortcomings and knowledge base as researchers and making sure that we're taking appropriate steps to sort of safeguard the processes.
Thanks, Kelly. Great tips. And I can see we've got one of our high upvoted questions is about the extent that the current journal publishing system is a barrier to open science. So I'm going to throw this curly one to you, Cara. From your perspective as a scientific director, as an author, as a researcher, where do you see this challenge or this tension between open science practice and journal publishing coming in?
That's a lot of hats. Certainly, I think that there are financial barriers, and I don't think that we should discount those. I was at the Canadian Science Policy Conference, I think 2 years ago now, when a researcher stood up in the audience and said, hey, I get credit for being a really great Canadian researcher. I published 10 papers last year, and the open access fees were $4,000 for each paper. So that's $40,000 in taxpayer money that's going to open science fees. What is the government doing? And I know that the Office of the Chief Science Advisor has pursued that question. I know some of the granting councils have pursued that question, asking if Canada can make agreements. If the National Library could make an agreement about charging for open access fees. We've also heard that some publishers make a 30% overhead earnings on these open access fees. On the other hand, it does take some administration and coordination to publish and edit and make sure that it's done well. So is there a tension? Yes. I think the default should be open access. I think that it's kind of like sex and gender. Might it cost a bit more money? Could we look for efficiencies? Yes. But otherwise, are we not living up to the expectation of what constitutes scientific excellence and what is responsible conduct of research? Think of all the money that we're actually wasting by everyone not sharing their data and the duplication and primary data collection that's happening because you don't know that somebody else has the answer to the question that you're seeking. So I'm 100% in favor of open access. I don't think it should be much of a conversation. I think we're facing a logistical issue. I think we're facing okay, you know, I don't want to say be like Nike, but let's just do it. And let's put those, you know, let's put the requirements in place and let's hold people accountable. There was a question about science security, and I suspect that folks were referring to the federal government task force recommendations on science and security. There were 17 recommendations made to government, I think in 2019, and science security is one of the priorities for the Deputy Minister Champion Committee on Science and Technology. But the Office of the Chief Science Advisor has, you know, laid out a roadmap for open by default. So certainly confidential business information, or if it's, you know, policy threat to Canada, then maybe no. But the instances are really rare and far between, and there's a way to anonymize. And I think that should be the exception more than the rule, and we'll deal with the exceptions. So is there tension? Yes. How to break through that tension? I think folks in this audience should just step up and start putting this into action. That's my recommendation. That's what we did with Sex and Gender. So it worked. People weren't happy. There was pushback. There was a lot of pushback. But did we do it? Yeah.
Thanks a lot, Cara. And Michael Hoffman has comments.
Yeah, I just wanted to follow up on the journals. First, I think journals can have a big role in improving open science. So especially in terms of ensuring that data is shared and code and other materials are shared. And some journals do a really good job of this. And I think this is something where, you know, I'm a big booster of preprints. Everything my lab does goes up on a preprint, but no one is going to check that we've actually made all of our data available for the preprint. It's the role of the journal to do this, and that's the best place to make sure it gets done, because you can gate that journal publication on whether the data is deposited, right? It's absolutely the best place, and journals have a huge role. On the other side of things that Cara was mentioning, the costs of gold open access. So there are real costs involved in running journals, and I think that journals are you know, worth a lot, and you know, those costs can be thousands of dollars because it costs money to administer, run peer review, you know, copy edit, whatever. I think we're getting into a problem though, where some journals are just jacking up the price really high, right? And that might reflect some additional costs because they are trying to make a really selective journal. And if you reject 90% of the papers that come in just to become more selective, just to make your journal impact factor higher, then it will cost you more to operate that journal. And then you get journals that are charging more than $7,000 to publish a paper in them. And I don't think there's any added value there for the taxpayer for paying $7,000 for a journal article versus $4,000. So I think this is going to keep going up and up until there's a hard ceiling put on it. And I think funders need to say, hey, you can't spend more than $5,000 on publishing a paper. Like after that, it is not something that actually benefits the public. It is something that mainly benefits people's CVs because they are chasing a higher journal impact factor, and it benefits the bottom line. So to summarize, you know, paying article processing charges, you know, paying for journals, I think that benefits the public. Paying really high charges so that people can get higher, you know, more popularity, more selectivity, I don't think that's a benefit to the public. We got to.
Thanks, Michael. We like strident comments like that too. So thanks for your passion. I can see that we've got another question that has got some consistent upvoting. So let me go to this about a semi-quantitative rubric and what would that look like. Now, I'm going to direct this back to David, I think, because we're talking here about assessing researchers. So how would you bring in the numbers versus the qualitative aspect of assessing researchers, David? Just unmute your mic, David.
Thank you, Claire, on both counts. I think quality is not a word I like to use too much because it means saying different things to different people. I think probably what I would like to see is the use of data sharing. I would like if I was the dean, I would like to see that my faculty in not only tell me that they've published, whether it's 3 articles a year or 53 articles a year, that they've actually shared their data. I would be particularly interested for my faculty to tell me that their data was reused in a replication exercise. I would be particularly interested in seeing whether my faculty have registered their research. I would be particularly interested to see whether my faculty have actually written protocols. Some people may call them quality indicators. I'm calling them transparency indicators. And that's part of the bigger picture of sort of open science. Those are the sorts of issues that I would like to see, because first of all, we have evidence about them. And I think that like other things in life, if we use evidence to inform our policy and our decision, we're going to be in a much better position than using something like a journal impact factor, for which there is evidence that you shouldn't use it. And so we need to really work in that direction.
David, I'm going to open this one up to the floor for other comments, because all of the speakers, as you've heard from them all, great thoughts and ideas about how we can change the way that researchers are assessed and how that has flow-on effects for how research is conducted in Canada. So Cara and Kelly, I'm looking to you specifically for some comments, and then we can come to Ellum and to Michael.
Sure. I think that behavior change starts with individuals. Certainly with the tri-council, tri-agency requirements coming down in coming years, we're going to see greater pressure put on institutions to do exactly, David, what you're recommending that they do, that there be, an open and transparent dashboard around open science. I think we've seen some movement in the EDI space, in the equity, diversity, and inclusion. For instance, when the Canada Research Chairs were, had conditional funding based on equity, diversity, and inclusion action plans by the university. So I think my recommendations to folks listening in right now is, why not be a leader in this space? Why not speak to your dean or your VP research? Or if you're in government, why not propose that you be a champion for open science in your department, and come forward with a recommendation of what your workplace, whether it's academia or whether it's government, can do to be a leader. And I think you've heard a lot of tips here. Collecting data is no small feat. So even just putting together a vision for what a dashboard might look like, we always, contextualize to Canada. I would say go ahead and, make a proposal and be a leader. That's pretty much how things get changed. Don't wait for other people to do it. There's a lot on the table right now with COVID, with racism, with Indigenous reconciliation. Like, no one's ever going to say to you, okay, please come do this. So just go ahead and start. I think that's one thing. The second thing that I wanted to add to what Michael said is, I once saw someone suggest almost a pyramid scheme for changing the way we finance open science and publication. And that would be where anyone who submits an article, let's say, pays a $250 submission fee. Right away, you could see how that would fund journals. Whereas if you get sent out for review, maybe you have to pay an extra $500. And then if you get accepted for publication, maybe it's $1,000. But you could see how the pyramid of having people pay to submit is not just, oh yeah, let's throw it at that journal. I know it won't get accepted, but maybe we'll get reviews and then we'll be able to go on to the next one. That's not an efficient use of resources for the system. So there are innovative ways to tackle the cost scheme that I think need to be at least put on the table here.
All right, Kelly.
Yeah, I can add. I think that, for example, I'm not sure I agree with the pyramid scheme of publishing, but I like that it's different than what we have, because I think right now we know the system's not working. We know the system of publishing isn't working. We know the system of evaluating researchers isn't working. So the question was about, how can we move from these quantitative metrics like number of publications and impact factor and do something more qualitative in getting at these things that we think are important but aren't currently being captured. And I think just like with publishing, when it comes to evaluating researchers, a lot of people have recognized, okay, the system is broken, but like it's the system that we're all familiar with. It's the system that the senior people have made their careers in, and it's just easy, right? So I think that what we need are these innovative ideas like the one Cara threw out with regards to publishing. We need these ideas put on the table. We need a discussion among stakeholders about which seem to make sense. And we just need to try. We need to come up with, for example, a new type of CV or new types of metrics that we would want to use. And then we need to evaluate if they're effective or not. So at this point, I think it's a really exciting time because we can be really creative. We can really reimagine the system that we're in and, look at how we might better measure things that we're not currently measuring. And then importantly, evaluate that, because we don't want, new systems that are equally problematic or worse or not making a positive change to be implemented.
Thanks, Kelly. Let's just continue on this metrics and measuring for a moment. I'm going to go to Michael first, and then Elham, I've got a specific question to you about teaching and embedding open science principles in undergraduate curriculum. But Michael first on the metrics.
Yeah, so, we were asked about semi-quantitative approaches to impact. I mean, think about, say, a course, a course for credit in the humanities, right? People aren't going to have exercises that they can get the right or wrong answer on, right? But there's usually more to someone's grading than the instructor at the end of the semester saying, I think you get an A, I think you get a B, right? There are rubrics. There are rubrics based on, this part of your coursework gets you this much credit. And then, going back to that piece of coursework, if it's, say, an essay, there's often a rubric from there. Like, this is, it's important to write your essay this way, and it needs to be mechanically important, and you need to pick a good topic, and all that sort of thing. This is the sort of thing we can transfer to researcher evaluation, where you can have qualitative assessments of things like quality, of things like impact at the individual research output level, right? Things that people can discuss and agree or not about, and combine them in a way that is predictable and understandable to the researchers under evaluation to make a kind of score at the end. And I think this is something where, by setting out a rubric, you have to say in advance what your values are, right? And then it becomes a lot easier for people to discuss, whether a particular paper met some sort of, quality indicator, rather than, I think this is a good researcher versus a bad researcher. Now, if you want to discuss that more, I'll be on Twitter afterwards too.
Thanks, Michael. And can you pop your Twitter handle?
Absolutely.
Can find you and discuss further. Elham, you've been quietly listening and taking all of this in, so I really want to get your perspective now, and I've got a specific question from the Q&A for you. And the question is about practical ways to teach at the undergraduate level, people who are beginning their research careers or thinking about research careers. How do we teach them these open science and open scholarship principles, and how to implement them? So not only what they are, but how to get them into practice, and perhaps how to change culture, because I think as a beginning researcher, you might find yourself in a scenario where open science is not as well embraced in the real life research lab where you go into as it might have felt like it was going to be when you were learning about open science. So what's your advice, and what are your experiences, Elham?
Thank you so much. So I guess before answering the question, a couple of points that were mentioned earlier that I would like to highlight. For example, one of the mentions that Cara mentioned, the points that Cara mentioned was about, being the champion and being the one who takes action and, takes the first step. And I think, a major kind of takeaway image from or idea from my presentation was the fact that, you have to start early with the concepts and implementing movements like open science. And as a student, even in the undergraduate level, and no matter where you are, in your research career, academic career, you have or should be taking the first step, because you can. And you essentially, by taking the first step, you're able to contribute to essentially strengthening the open science movement and making the difference. And I guess this also ties to Dr. Kobe's point about creating these new kind of innovative but equally effective or even more effective approaches to implementing open science, and learning from the past systems that were put in, and how to improve them and what changes we can make. And as a student in your early academia or academic career, research career, you're able to essentially allow for contribute these innovative ideas, and by essentially championing and taking the first step. So just to bounce about the past ideas that were stated, in terms of my experiences and what I see to be the most fit way to implement teachings of open science. As a student who's early in their undergraduate career, I think I have been invested and interested in research, and through the research courses that I've been taking currently, there is a mention and implementation of the underlying basis of open science. Like I mentioned, there was the teachings of open data and data sharing. However, the concept of open science itself, I don't think is clearly taught. And so I feel like there's kind of this gap that then students face after when they graduate or from their undergraduate into their graduate, or apply to these graduate schools. They're suddenly then introduced to this concept of open science formally. And so in order to kind of bridge this gap, I think, you have to break it down, because research and open science, it is such a nuanced and multifaceted, idea that you need to learn. It's a skill you need to develop. And, with age, you're able to do so. And with practice, by even from the undergraduate, from, just a couple units, for example, in the course, in their introductory research course, then you build off of that in the next semester, and so on. And over time, this gap is going to get covered. It's going to be built through. And then when students are actually graduating and reaching their graduate positions and even their employment positions, they have this skill that they've developed. The foundation is strong, and so they're able to successfully implement open science. So just a couple of perspectives there.
Fantastic. Thanks, Ellen. And we're getting to the top of the hour, so I think we might be up for one last one if folks are okay with that. And we had a specific question from Sabrina, and asking us to speak the relationship between open science and intellectual property. So this sort of tension between open science and IP, and I think we've alluded at it, glanced at it. I think it got voted to the top. So a very democratic, open group here. And so why don't we address that directly? Can someone speak to the relationship between open science and intellectual property? And should open science practices consider the value of intellectual property? So it's word for word from Sabrina. I'm looking, perhaps Michael, if Kara's,
I'll say personally, you can hear me? I'll say personally, despite signing on for the session, I don't actually like the term open science because it conflates a lot of different things. And I don't like the term intellectual property for the same reason. But when people in academia talk about intellectual property, usually they mean patents in my experience. And there's not much contradiction, I think, between open science and, say, people applying for patent applications, right? You just have to apply for your patent application before you make whatever it is public. Now, that does, get in the way of some of the more extreme visions of open science, like, open lab notebooks as you go. But it's, trying to write a patent application, as long as you do it before you publish your paper, it doesn't get in the way of other people being able to look at your data or, reuse your methods for research purposes.
Just going to jump in here. I think we've lost audio from Michael, and I can see that we're due to wrap up in about 45 seconds. So let me do the final wrap up here. Sorry, Michael, I think you were going to say that it is possible to have intellectual property slash the big term there and also practice in an open way. And I think I'll close with the point that open science is much more than open access. So please, if you take nothing else but that point away, we'll all be happy. So please all join me in thanking you for jumping on this session today, and thanking all of our wonderful speakers and great panel discussion. I'm glad we had the time to connect. Thanks for connecting and making it such a great session. Thank you, everyone, and goodbye from us.
Take care. Bye-bye.